Hi everyone. Today we're going to look at integration. We're going to integrate functions from multivariable calculus. What we are mostly familiar with is integrating functions from single variable calculus. What that means, in single variable calculus, we are simply using one dimension to calculate. If you have a graph, a function like this is f of x, this function, and you want to find the area of this function, the area under the curve, yeah? You draw your lines here. If you say this is A, B, so then you are going to integrate from A to B to find the area under this curve. Where do we use this? We use this mostly if you have like a distance time graph. Distance time graph. You want to calculate the area under the graph. This is why we use single variable calculus. That's what I use this. But we are interested in the multivariable calculus, integrating functions from this topic. Why? Because this is more real. Here we are dealing with two dimensions. If you have a function f, it's short that all real numbers are mapped to real numbers. We want to find the volume enclosed between the surface z f of x, z equals f of x, the plane xy, and the vertical planes x equals a, x equals b, y equals c, y equals d. Where do we use these kind of things you heard about? Mostly we use this to calculate the volume under a graph, and in real uses you can do that to calculate the mass of objects or the moment of inertia of objects, if you want, center of mass of objects. It's more physics and engineering, very important for them. So this is what you have. This is in two dimensions. We want to calculate, this is a function. Say you have this box, for example, now. It's a function, actually, a graph. And you want to find its volume. So you're going to use the surface. Yeah? Z equals f of xy. And then the plane xy. And then plus these vertical lines, you have this one going this way, this one going that way, to find the volume. Let's do an example. Let's try to solve an example, and then you see how problems involving this type of idea is dealt with. Again, we'll be doing single variable and multivariable so that it will be simpler for people to absorb the idea. If you are given f of x equals x squared, and now they want you to integrate f of x, which is you are integrating f of x dx. You are integrating x squared dx. This is single variable calculus. Why? It's only one variable you have here. Here you can see you have xy, zxy. Here you have only y equals x, or y x equals, or some other letters. The formula for integrating a function, if you are given f of n you want to integrate x raised to the n dx, you will have x raised to the n plus 1 all over n plus 1 plus c, where c is a constant. We'll have this constant because there are no limits here. You've not been given the intervals. When you are asked to find the area of something, they must give you intervals from this, starting from this point to this point. So that is it. We don't have these points here because we don't have them here. That's why you have this constant plus c. If something was here like 0 to 2, you don't need this c. These numbers account for the c. So this is what you have. Now, let's look at a real problem in multivariable calculus. I just brought single variable calculus to see the comparison. We don't need it here. We will deal with multivariable calculus. Yeah? Let's solve one problem. And multivariable calculus deals with two integral functions. What I mean by that, single variable calculus, you're given f of x. You have this integral function here, f of x dx, to integrate. Multivariable calculus, you will have this and f of x dx dy. You might be given intervals here, c, d. So this is what we're going to be doing. This one, this is single variable calculus, this is multivariable calculus. This is what we're going to be doing. Let's see one example. Let's solve one problem. It says find the volume enclosed between the surface of z equals 8 x cubed y plus 3 x squared y squared. Find the volume enclosed between the surface z and the plane Plane, the plane, the xy plane, xy plane. Something was wrong with the ink. And the vertical planes and the vertical planes x equals x equals 2, x equals 3, y equals 1, and y equals 2. So that's the question. That's the question. You are asked to find the volume of this function under the surface and the plane and the xy plane, including the vertical planes. You know, we drew the diagram before. You can see the y planes and the x planes. That's what it means. And then the top and the bottom, the xy plane and the surface. So let's now interpret this problem into a mathematical way. Now you have what they are saying here. You have this integrating. Integrating again. And then you have 8x cubed y. This y has something. 8x cubed y. Easy. Okay. 8x cubed y plus 3x squared y squared. We have in the x dy. The y, we are told, now watch, most people make the mistake of writing these functions in the proper way. When you have the x first here, it means this second integral has the x. This one here, the outer one, the y, it means the y goes with this outer one. The outer one, outer goes with the outer. Inner goes with the inner. Some people interchange by mistake. The y, when you say here the y, that is the outer one. So the y starts from 1 to 2, because if you write them wrong, you get the answer wrong. And then x plane, which is the inner one, starts from 2 to 3. So this is what we have interpreted here. Now let's start solving the problem. We are going to start with the inner one, the x. So which means we are going to look at x variables only and consider y variables to be constant. So then you're going to have 1, 2, we are now integrating the x, the inner one, 2 to 3. That's what we're integrating now, 2 to 3. Yeah? So you have 8x. If you integrate 8xy, you're going to get 8x to the 4 all over 4y. Y is constant. You are integrating with respect to x. Yeah? So y is constant. So you get, you remember that formula we use? That's what we are using here. Integrating x to the n, you will have x to the n plus 1 all over n plus 1 plus c. This is what we are doing. Here, our n is 3. So because n is 3, it's going to be 3 plus 1 all over 3 plus 1. That's what we have here. So now you have plus. If you integrate this with respect to x, you're getting 3x to the power of 3 all over 3y squared. That's done. Then you have your intervals, which are 2 to 3. Then you still have your dy now for this second part. So now we're going to simplify what we have done here. This is 1 to 2. You now have 4 can go into this. 2 to the power of 4y plus 3 cancel each other, 3. So we're having x cubed y squared to 3 dy. So let's simplify. Now we put in 3 space of x. So 3 raised to the power of 4. Is it not 81? 3 times 3 times 3. 3 raised to the power of 4, 81, yeah? So 81 times 2. 162. 162 y plus 3 raised to the power of 3 3 times 3, 9, 9 times 3, 27. So you have 27 y squared minus, now consider 2 raised to the power of 4, 16 times 2 is 32y minus 2 raised to the power of 3, 8 here is 8y squared, 8y squared, and all this is dy, put it out loud, dy. Okay, now we'll simplify. We have, I will take off this one at the top so that I can have more space. Yeah. I hope you follow. We'll simplify now. This is minus 32y, this is 162. So what is left? 130, yeah? So now we have this function, 1, 2, 2. We'll have here 130y. This is 27y squared minus 8y squared. So this will be 19y squared plus 19y squared. So that's what we got here. dy. That's all we have. What is left? I hope I haven't missed anything. Yeah? So now we integrate, further integrate this one. If you now integrate this one here, you're gonna get 130y squared all over 2 plus 19y cubed all over 3, 1 to 2. When you integrate this again, 19, this will be 3. That's why we have 3 at the bottom. So again, let's simplify. This is 130, 65 here, 65 y squared plus 19, you can simplify this, y cubed, 1, 2. So when you put 2 here, you're getting 65 times 2 raised to the power of 2. So 65 times 4, you get 2 raised to the power of 2. Plus, you have 19 all over 3. Now, 2 raised to the power of 3 times 8, yeah? Then you have minus. Now, consider the 1. 65 raised to y raised to the power of 1 is just 65. Yeah? Minus again, this side now. 1 raised to is just y raised to the power of 1 raised to the power of 3 is just 1. So this will be 19 all over 3. So this is what you get. Now let's simplify. Let's simplify. Why do I have 8 here? Oh yes, because of 2. So 65 times 4. 130 is 260 there. 130 is 260 here. Plus 19 times 8. So need calculator, please. 19 times 8. This is 72, carry 7. 8 plus 7, 15, 152. 152 divided by 3 minus 65 minus 19 all over 3. So we can bring these two together, 260 and 65. This will be 260 if you be 195. So we have 195 for this one and this one, and this one 152 152 all over 3 minus 19 all over 3. So what do you get? (152 minus 19). This is 12 is 3. Now it's 4. It's 3. 133. So 133 over 3 minus 133 all over 3. I'm not using calculator, that's why we are spending time. So now we have, this is what is left, the entire problem. Let me just say this is I equals to, now I equals to 3 times 5 is 15, carry 1. 3 times 9, 27, plus 1 you carry, 28. 3 times 1, 3, plus 2, 5, minus 1, 33 all over 3. So here you get 2, 5, 4 all over 3. So this is your final answer. If you put here 1, 15, 5, 20, yeah, 51, 15, 5, 2, 6, and 56, 1/3. No. This is what you get. You can simplify this one using a calculator. Yeah? Simplify this one. I hope this helps. Thank you.